Assalamu alaikum. Good morning, everyone. We are here to present our group project proposal on hospital management system. Our team consists of 4 members: MD Riyad Hossen, KM Akib Azmain, Mostafizur Rahman, and me, MD Shihabun Sakib Tamim. In this presentation, we will explain the main idea of our project, its objectives, and how it can be implemented. Here are the objectives of our project. Design and implement a full-stack hospital management system using DSA principles. Apply core data structures, arrays, queues, hash maps for managing doctors, appointments, blood bank tests, and ambulance requests. Demonstrate how efficient algorithms improve real-world healthcare workflows. Evaluate time and space complexities of the implemented algorithms and data structures.
Now, I will introduce our hospital management system. This is a web-based healthcare platform with two main modules. The first is the patient public portal, where patient can book appointments, check blood availability, view lab reports, and request an ambulance. The second is the admin dashboard, where hospital staff can manage doctors, appointments, blood bank inventory, lab test, and ambulance services. This system makes hospital services faster, more organized, and easier to manage. Next slide. Before developing our system, we identified several problems in traditional hospital management. First, patients have to wait in long queues because there is no proper appointment or token system. Second, blood availability is not easily visible, which causes delays during emergencies. Third, lab test records are maintained on paper, making them difficult to search and manage. Finally, ambulance requests are handled manually without proper tracking, leading to communication and coordination problems. Our hospital management system is designed to solve all these issues. Next slide. In this project, we applied several data structures and algorithms. We used arrays to store doctors' appointments, tests, and ambulance requests. We used a QE for appointment token generation, ensuring patients are served in the order they book. We used linear search to find doctors and filter appointments or tests. We also used a hash map to store blood stock, allowing fast lookup and updates for each blood group. Finally, we used filter operations to display doctors by shift and to remove records efficiently. These DSA concepts helps make the system faster, organized, and efficient.
So now that we've seen the problems we aim to solve, let me walk you through the core logic of our system. We'll explore how we have applied data structures and algorithms to create a functional solution. Okay, there are three key algorithms we used in our hospital management system. So first, the appointment booking algorithm. This is a perfect example of how we utilize our data structure in sequence. The process begins when a user selects a doctor from our doctors array. Then choose their preferred shift and visit type. After validating the user's data, we generate a unique token for them. Okay, so next we calculate the fee. We use a hash map to perform a big O of n time complexity on the doctor's record to find the correct fee for their visit time. And also, we construct the complete appointment object and append it to our appointment array. Okay, so the next one is blood bank update algorithm. Okay, so an admin selects a specific blood group which acts as the key K. Then we enter the new stock quantity, the value V. Then the core update is a simple assignment like blood stock K to V. This direct access gives us an average big O of one time complexity. Then we save it to local storage and instantly re-render the display for the admin. Then lastly, search algorithm. And this is highly useful feature for patients and staff. It's our most computable heavy operation. Then we have time complexity. This brings us just not enough to build the system. We must evaluate its efficiency. Though by this table we can see the clear summary of how each core operation performs in time in terms of time and complexity. So let's to give you a highlight. For booking an appointment and updating blood stock, we achieve big of one time complexity in both best and worst complexity cases. And however, operations like finding ID, searching for the catalog, or filtering doctors by shift, all kind of linear search resulting to an worst time big of n time. The space complexity is more for most of the operations is big of n. Then we have recurrence relation analysis. Okay, so let's dive in a little deeper, like the sequential array scan, which includes filter and linear searches, can be described by the recurrence relation. For the string search, it's also the same. And the most important thing is hash map operations. Without it, it is impossible for us to make as efficient as possible. Okay, to conclude this section, it's important to be transparent about both the strengths and weaknesses of our current implementation. On the positive side, the advantages, it's a zero backend, zero dependency application, meaning it runs instantly in any modern browser. We have successfully achieved big of n blood bank operation and a fair FIFO and as first in first out token system, providing the right data structure solves real world problem efficiently. And also it is a bilingual interface like Bangla and English. You can use any kind of interface and switch between them for local people and international people however you want. And also there are some disadvantages, like we have the local storage, it's like 5 MB capacity, makes it unusable for large scale hospital deployments, like when you need a large database. The lack of any user authentication or multi-use synchronization means it is a standalone tool, not a fully network system. Finally, the linear search, that is big of n, will degrade the performance as the hospital management grows up and the database increases, and it will degrade the performance because of linear search.
Now we can see the public panel. From here, a patient can see today's available doctors, test prices, blood bank stock. They can also book a serial and request an ambulance by submitting their location. Very simple and easy to use. Next slide. This is the admin panel layout. The admin can control everything from here. Add or remove doctors, update test prices, manage blood stock, view bookings, and track ambulance requests. So full control is in the admin's hands. Next slide. To conclude, we have built a healthcare management system with two main parts: a public panel for patient to get services easily, and admin panel for full control. The system works well and makes healthcare services more organized and accessible. Next slide. For the future, we want to add online payment, doctor patient chat, SMS or email notifications, a mobile application, AI-based disease prediction, multi-language support, and bed availability tracking. This will make the system even better. Next slide. Here we can see the references. Next slide. Thank you, everyone.